Hey guys, what's going on? My name is Itzik. Thanks for being here with me at Secret Summit in the Dev Corner, where I'm gonna tell you guys a little bit about what's new with Secret Network, um, what we just got done doing, and what's coming soon as well. Things that you can be excited about now are Shockwave Omega, the latest network upgrade. We added a new WebAssembly engine. That means improved performance across the board and reduced gas prices as well. So everything becomes faster and cheaper. The other thing is SecretJS 1.5. And SecretJS 1.5 changes the APIs that SecretJS uses to use the gRPC gateway APIs, and I'll talk a little bit about why that's important in a bit. And we also added support for React Native, so those are your mobile devices. That's what we just got done doing, but what is there to be excited about in the future as well? So first of all, we have seed rotation. That's a key feature for the network security. We have privacy as a service, or the ability for Secret Network to be that privacy hub in Cosmos, but also in any other IBC connected chain as well. And the first feature in privacy as a service is going to be the random number generator. Support for new hardware. We're going to add decap attestation support, which will enable node infrastructure providers to run third generation Intel hardware. Secret contract features, specifically iterators and contract migration, which have been big features for contract developers that is currently missing in the developer experience for Secret Network that Cosmos developers have come to expect. And lastly, we just got done doing some major performance updates and improvements, but we're not done yet. We still want to take our current WebAssembly engine and upgrade that again as well to get even faster performance. So I'll dive a little bit more in depth about those things that I talked about as a highlight. So first of all, our new WebAssembly engine, we switched out from the old WASM engine to WASM 3. And what that means is 3 to 4x performance improvements across the board, basically. So in CPU heavy workloads, as you can see in this expertly drawn graph, WASM 3 is about 3x faster in our environment. And that's also computations that happen inside a contract, but also another important part is the contract startup time as well. And in fact, in most of the applications on the network right now, the contract startup is the heaviest operation. So the actual work that happens in the contract is actually smaller than the contract startup itself. So this will mean a lot of performance for all the apps on the network. Everything's going to work much faster. Things working faster also means that we can also take a look at gas costs and normalize them to what the computational cost is. And what that means is basically we want one gas to equal x computational time, so you can't spend more gas than a block can compute. So blocks are about 6 seconds, and currently about you can fit 8 million gas in a block. And the point of the gas prices is to make sure that you can't use more than 8 million gas to take up that 6 seconds of computational time. as a part of the Shockwave Omega upgrade, we also took a more in-depth look at gas costs using the new WebAssembly engine. And we also wrote some benchmarks to give us a more in-depth look about what the actual costs were on Secret Network. And we arrived with numbers that will end up reducing gas prices by about 3x. It depends on the specific contract, but with the new engine, we were able to reduce gas costs almost across the board, with the default instruction cost actually getting increased because it was just too cheap before. So now things will make more sense. And yeah, but for the most part, for users, you'll see greatly reduced gas costs in almost all network applications. Okay, SecretJS 1.5. Yeah, as I mentioned, gRPC Gateway, it's a big feature that we really wanted to add. And I'm really glad that we could get it done in time for Shockwave Omega. And if you're not aware of the different interfaces or the ways that you can interact with nodes in Cosmos, there have been, at first there was, this old REST or HTTP interfaces, and those were really slow. They were really slow, but they were easy for developers to work with. But then came gRPC interfaces, and gRPC interfaces are binary interfaces, which are harder for developers to work with, but they were much faster. So SecretJS 1.4 used those gRPC interfaces, which were faster but harder to work with. And now with SecretJS 1.5, we transitioned over to gRPC Gateway, which is basically the best of both worlds here, where you have your HTTP interfaces that are easy for developers, easy for infrastructure providers to load balance and cache and extract the most performance out of your nodes, but with the performance of the gRPC interfaces as well. So you have that easy to use but also fast interfaces, and those will make all the apps on the network much easier to scale, much easier to work with. And specifically, Kepler is a big one that has been using the old slow REST interfaces, and now when they will transition over to SecretJS 1.5 and the gRPC gateway interfaces, it'll result in about a 10x performance boost. So really big. And of course, the other thing is support for React Native. So finally, SecretJS works with React Native. We'll start seeing mobile applications easily integrate with Secret Network and expose that privacy functionality with the blockchain, with Web3 on mobile devices, which is super cool. All right, so moving on, seed rotation. I sort of touched on that a little bit, but I'm going to really explain why it's important and why it's going to be super cool and also very useful beyond just security. So what seed rotation means is the ability to take the consensus seed or all the secret stuff stored inside the enclaves or the trusted execution environment and rotate that across the network. So the network can sort of take a look and see, okay, now maybe there was an exploit, or maybe something happened where we want to make sure that our data is protected. So as a network, we can take our secrets and change them. So you change your secrets in a way that synchronizes all the nodes. All the nodes get a new secret. You make sure that only nodes that pass security checks can get this new secret, and it is really protected. That allows us to sort of wipe the slate clean if there was any potential security breach or any potential compromise of keys, and it protects all future data. So it's really important from a security perspective, but from a feature and development perspective, what this allowed us to do is to create the basis for a couple of other important features. And the first is that it allowed us to take a look at the encryption schema of data on secret network, and we got this chance to tune and add a little bit to the encryption schema, which allows us to add support for contract iterators and migration in the future. Because up until now, it wasn't possible to do, because it just wasn't like all the keys in secret network, all the state is encrypted, so you don't have that ability to iterate over all the keys, because they're all encrypted, they're all scrambled, there is no, you can't make sense of anything. So you can't do iteration, you can't do migration, but then we added a couple of bytes that allow us to make a little bit of sense of things, and that allows us to do iteration and migration. It's not going to come right now, tomorrow, but now we can finally start working on it and finally add these cool features, in the short to medium term. Another super cool thing is decap attestation. So this is the it's a feature in SGX that is the new way to validate hardware, and that means that once we add that, it'll allow us to support the new third generation Intel server hardware. That means faster hardware, more efficient hardware, cheaper for node runners to deploy, more scalable, easier to buy, all that good stuff. Random numbers, I mentioned that also, and we're super excited about this. Like, we really want to add the ability to use cryptographically strong random numbers, both cross-chain but also on secret network as well. And the plan here is to add a random number that gets generated on each block. So contracts inside secret network can rely on every block or every transaction coming in with a random number, and they can make use of that. That number will be very hard to predict. Won't depend on block hash, timestamps, things that are don't have a lot of entropy and are fairly easy to predict. And this will be the basis for easier development of games, of things like loot drops, everything that random numbers are used for. And this will be also available for contracts on secret network, but also cross-chain as well. And of course, there won't be any fees here. This is not something that we're going to monetize. You just have to consume it cross-chain, and it's going to be super cool for developers across the entire Cosmos ecosystem. Yeah, contract development, I touched on this, iterators and contract migration. So iterators is the ability to iterate over keys in a contract. So for example, imagine you have a list of addresses of that have a balance of a token maybe. So you have a list of addresses that are owners of the token. So a useful feature is to be able to easily ask the contract, hey, give me a list of all the owners of of the token, or all the members in a specific data structure. And that's super powerful to for developers, and something that's gonna be coming soon. and contract migration as well. What I didn't mention about contract migration, and basically all features on secret network, which are a little bit more complex than your regular run-of-the-mill blockchain. Not that there is anything like a run-of-the-mill blockchain, but on secret network, as the core developers of the network, we always have to consider how new features impact the privacy of the data that's stored on chain. And contract migration specifically is an interesting example of those kind of trade-offs where if you don't know, contract migrations means the ability to upgrade a contract. So let's say you have a contract deployed. Let's say it's it's the secret contract. So let's say it's been running for 2 years, all good, but now we want to upgrade. We want to add the ability to support permits, which didn't exist way back when we deployed it. Right now we can't do that. So right now it's not possible to take a contract and deploy new code and transparently upgrade that contract. So you'd think that this is a fairly basic feature that you can see in other Cosmos chains. And you ask yourself, well, why doesn't that exist on Secret Network? And one of the reasons is that being able to upgrade your contract with new code inherently puts that data at risk. So as a user, if I use Secret and I trust it, how do I know that if new code is deployed, it doesn't have a backdoor, doesn't have a new bug, or maybe even something something else. So what we have to do to be able to keep everybody safe and keep developers, allow developers the tools to create powerful, scalable apps, but also protect users' data, is the ability to have certain permission types for contract migration. So the app developer will set the policy for their app. So you can have an app, for example, maybe it's super strict. So the app doesn't allow migration at all. Maybe it's a wallet app that stores private keys, and it has data that's super sensitive. Another option will be upgradability, but that has to be authorized by a specific address. That address can be either a contract, so maybe there's a contract that manages governance, a DAO of some sort, and they can approve, the migration of a contract. Maybe that address is a developer address, maybe it's a multi-sig, it could be anything. And the third type that we're considering is network-wide governance. Maybe there are contracts that are, of interest to the entire network, and you'd want to leverage network governance to upgrade those contracts. So we'll have a few different type of options, and developers will be able to choose what the right balance for their apps is. Yeah, and lastly, I want to tease a little bit about Secret 2.0, specifically about threshold cryptography. And this is something that we've started looking at. It's still in early development, but it's super exciting for us. So what we've started to look at is adding threshold cryptography to Secret Network. Specifically, the ability for validators to manage keys that are a part of basically a distributed key, or that they will be able to use together to generate signatures. So we'll be able to have, so basically what's going to happen is keys are going to get distributed to validators, according to their voting power. And once you have 66% of the voting power signing the same thing, that will basically be the threshold cryptography signature that will allow us to aggregate those signatures and derive very useful data from it. That could be random generation of random numbers. It could be protection of specific data, managing access controls, all kinds of things like that. And that will really be the basis and the first step to sort of moving away from SGX or trusted execution environments as a single point of failure, or as the only source of security beyond, what the network can provide. So this is going to be something that's super, super exciting, and I can't wait to share more, which will happen. I hope it'll happen very soon. And yeah, all these features together, those together, it's really where we're seeing Secret going. That's creating the best developer experience. That's creating, good performance, scalable nodes, mobile apps, next generation cryptography, and everything together, that's really where Secret is going. So yeah, thanks very much, guys. I hope this was interesting, and yeah, thanks for being with me, and see you in the next session.